let's start. How vision works. Okay. So there is light in this room, right? And then this light is reflecting from my body, from my face or whatever, and then it goes into uh, what we call cornea. So there's a cornea here, a lens, if you will, simple language. Okay. And then there is retina at the back of your eye, which is like this. And on the retina, there is a point called fovea centralis, right? And it's not important to remember that point, but there's a point, okay? And all this light actually focuses on that particular point, okay? So there's a lens here, lens sort of converge the light, and it sort of try to put all that light on that one single point. And then there are these optic nerves at the back, okay? And those optic nerves then take that signal, convert that light into electrical impulses, electrical signals, and then it takes that data to the back of your head, which is called visual cortex. Okay, at here, and all that light and all that stuff that happened is converted into an image. Okay, um, uh, yeah. So it's, you could call it an image, whatever that means. Okay, so then you start seeing things. So the reason why you're seeing me is because all this light is converted into electrical impulses inside your brain, and my picture is actually projected inside your brain, uh, back of your brain. Okay, so that's the mechanism of how we see, and now you must have noticed, I'm wearing these glasses. The reason why people wear glasses is because my lenses are unable to sort of uh, converge all this light on that point. So either it is uh, converging it before that point or after that point, and therefore I start seeing blur. Okay, and what this glass does, it helps that lens converge that light on that particular point, which is called fovea centralis. Okay, okay, so that's the way we see, really. Okay, well, we know, we could only see a tiny bit of the spectrum. The spectrum is huge, right? It's vast. So we could only see this visible light, right, which is a tiny bit. So I call it a big filter. So in fact, your brain actually filters out a lot of information which is there already, right? So obviously you can't see ultraviolet, you can't see infrared, but there are cameras which can see ultraviolet and, and infrared. There are ways we could use X-rays. There are ways we could use gamma rays. There are ways we could. I mean, we already use microwaves and radars and radio waves and all that stuff, right? So all this stuff exists. It's just that your your optic nerves, which is behind fovea centralis, can only decipher this part of the spectrum. Okay, and that's it. So we can't really see anything else. Um, and by the way, this spectrum is huge. So when you really see stuff, you see a lot of stuff. Okay, it seems we are seeing everything, which is not really true. We don't see everything. We just see a tiny bit of spectrum. Okay, I'm just letting you know because this is important for how our brain functions. Okay, um, and then this is sort of interesting way to decipher how your eye really see. So right now you're sitting, maybe besides a laptop, besides a mobile or whatever, right? Maybe you're sitting in a room, maybe you're sitting in an office or whatever, right? um, you think, or your brain thinks, you can see everything. Okay? That's what usually people assume. So for instance, you go to a park and you're standing there and you think you can see everything. Okay, but not true. Um, at one point, you could only see in detail a tiny bit, a very tiny bit. Okay, so an example of it is if you stretch your arm and if you look at your thumbnail, Okay, approximately that's what you could see in detail. Okay, so you could only see this much in detail, in full detail, at any given point of time. So if you convert your vision into frames, for example, whatever that frame means, okay, for each frame you could only see this tiny bit in detail. And what your eye does is, it fixates on that point for a little bit, and then it moves. So when it moves, it's called saccades. So there's saccades and fixations, and you keep moving your eye from point A to point B to point C to point D to point E, point F, and your brain is smart. So what your brain does is it keeps clicking those pictures, chuck 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 chuck, okay, and it gives you the illusion of, hey, I could see everything, but not really, not true. You could only see that one point at one moment. Okay, and this is how magic works, right? So if you notice, all magicians will try to focus on one area, and then they'll do something here because they know you have seen this before, but now you're not seeing this hand, and I'll do something, but in your head it seems, oh, magically something vanishes. Okay, but not really true. So you are not paying attention to that part, and they understand that, they know it very really really well. Okay, um, because, and I'm talking about English speaking, Hindi speaking people, huh? So that language, which goes from top to bottom, left to right, and the reason is because the way we scan our websites, our applications, is from top to bottom, left to right. Okay, and usually there's this F pattern that is a very common pattern. So if you notice here, so there is an F. You know, it's a heat map of your application or website. Here you can also see F here, right? Um, that's the way people. So they'll start from top left. Okay, so they'll scan this part. All right, they'll go bottom, and then they'll scan this part, and they'll go here, and then they'll just go away. Okay, so that's usually people scan a site. Now, if you notice, nobody actually is going to these areas here, right? So, and this is a little older clicks, older pictures, but even here, nobody's really going here, right? And if you remember our old school ads, people, so your brain is trained not to look at this because, even though there are icons here, even though there are images here, right? Look at this image here, right? So even though there's an image, and an icon, your brain is ignoring that area. Okay, because you're assuming it's an ad, which means don't put important stuff here. Okay, it'll be ignored. And then there are some things which are sort of highlighted, right? So if you look at this one here, I don't know what that is, but it might be moving. Right? There might be some stuff which is sort of wiggly, moving or whatever. So your brain tend to see moving stuff. Okay, so I don't know if you see my hand moving. That'll grab your attention. Okay. Um, you know, again, the way I work, the way vision works is, vision, your eye will by default focus on complex areas. So if there's a simple thing and there's a complex thing, it tend to move towards a complex thing. Okay, that's the way it starts. I mean, after once you have seen the complexity, it can then move towards the simple thing as well. But it'll go to the complex thing first. Okay, if there is a saturated color versus unsaturated color, it tend to look at the saturation first. So in case of these two pictures of Superman, um, invariably you look at the saturation first, right? The one on the left, I'm assuming, right? That's where it is. And then obviously once you look at it, you can then move your eye to the right as well, because that's probably newer, right? It's 2013. Um, If there is stuff which is light and dark, human eye will tend to move towards darker areas first. Okay, that's the way it works. And then from there, you could then move to a lighter area, and then we tend to see human faces, right? So, and I think we discussed that yesterday as well. So human eye tend to spot faces, and then there'll be a fixation there, and then from there you could obviously move to a different area, and there is no science to it. So there is no really formula to it. Should I have a complex area? Should I have a saturated color? What saturation colors should I have? How much darker the area should be, right? There is no really a formula for it. um, but you could use these things, these ways to catch attention. So if you notice in the past, and in many websites, they used to have this gradient, right? Center gradient. And they used to also have this human face, looking at you, with a gradient. And there's a reason for it. And I mean, we used to simply copy and paste that design because it used to work for some reason. And we didn't know why it used to work. And I'm telling you, this is the reason why it works. Um, if it's a gradient, so there's a darker area, there's a lighter area, human eye will invariably go to the darker area first. Okay, and then because it's a gradient, it'll move from dark to light, and then here there is a big button which says sign up now, whatever, right? Or click here, whatever. So call to action can be at least looked at because of gradient, right? um, Human faces does the same thing. Human face, the first thing it'll does is it'll grab attention to a human face, and then from there on it moves somewhere else. But then these things can be used to grab attention of your users, right? Okay. So now, you could then look at an application and review that application for these aspects. So for complex areas, saturated colors, dark areas, human faces, look at based on the vision, based on top to bottom, left to right, based on saccades and fixation. So if you now you know all this, you can then go back to your own application and see, okay, so based on that logic that Manish told us, where do I think people will start on my website, on my application, on my app? Okay, and oh, this is important for me. So what do I do to make sure people see this call to action, or people see this message, or people download more, right? So you could use this logic to review your own applications, and this is based on how brain works. This is based on how your human eyes see things. Okay, and if you're a UX designer, you could then also give reasons to your business folks, to your visual design folks, saying, "Hey, this is how human eye works. We got to make sure, we have saturated colors for our big button because it grabs attention."